Good morning, guys. We're gonna skip 9.2 because it's a class I actually want to give you guys in person. It's just graphing polar coordinate graphs, or polar equation graphs, actually. Today we're gonna work on 9.3, which is converting polar coordinates to rectangular coordinates and vice versa. 9.3 is split up into two parts: coordinates and equations. Today we're gonna focus exclusively on converting coordinates, and you need to know how to do this in order to work with tomorrow's class. So again, today we're gonna focus on just turning a rectangular coordinate into a polar coordinate and vice versa. Tomorrow we'll go over the equations. Now, to convert a polar equation into a rectangular equation, it is very simple. Now remember, a polar equation pretty much gives me an angle and a distance. Yes or no? I know that if I were to place a Cartesian, a coordinate axis on top of the pole, would this not turn into a triangle? And from that right triangle, would this not be my x-axis? And would this not be my y-axis? And would this not be my hypotenuse? Yes. Don't say, all you have to do to turn a polar coordinate into a rectangular coordinate is use this very, very simple formula. The distance, cosine of that angle, that would give you your x value, and then the distance sine of that angle. Maybe you'll ask, Profe, but why? Why cosine and sine? Remember, when we put our right triangles on top of the unit circle, the x value was, you can say x is the same as sine cosine, and y is the same thing as sine sine. Don't say when we're working with these circles, r cosine of the angle will give you x, and r sine of the angle will give you y. So you're going to use the exact same r and angle on both. All that changes is the cosine or sine if you're going to use your x and your y values. Use calculators to find the proper answers at the end. But before that, let's do an example. Let's say they give me, let's look at example 1 in the book, and let's go over A. They give me 4 pi over 16. I know that my r is 4. I know that my angle is pi over 16. So all I gotta do is r cosine of pi over 16 to get my x value for my rectangular coordinates, and the same r sine of the exact same angle to find the y value of the rectangular coordinate. You plug this into your calculator, multiply by 4, that's going to give you the proper x's and y values. You can look for the answers in the book. Now let's go over how to turn a rectangular into a polar. Now this isn't as straightforward or simple as polar to rectangular. Polar to rectangular, again, you just plug in the values, one step, boom, done. In order to find the rectangular, in order to find the polar, you have to use your x's and y values to find your distance, and those exact same x's and y values to find your angle. Now let's go over the distance. First of all, when we look at a right triangle, they give me a particular x and y values. That's my awesomely drawn, perfect right triangle. If I were to just put a circle on top, again, that's my perfectly drawn circle. That's actually a pretty bad circle. If I were to put a circle on top of that particular point and have this point be on the pole, let's try to make it more representative. Oh my God, this is a horrible circle, but when more or less that's the idea. If I were to superimpose a circle on top of that particular point and have the center be at the pole, would that not be distance? And if I'm focusing on the circle, That would be the distance from the pole to the point. But if I'm actually looking at the triangle, and that's a right triangle, would that not be the hypotenuse of that right triangle? So in order to find the distance, it's Pythagorean theorem. R equals square root of x squared plus y squared. I'm going to explain both, and then I'm going to do an example. So that takes care of our R. How do I find my theta? Remember, to find angles, we use inverse. The inverse of certain identities. In order to find angles, we use the inverse of certain identities to find angles. Now, since they're giving me a rectangular coordinate, would they not give me a y and an x? Again, I'm focusing right now on just the triangle. And what identities work with y's or x's? Or also the sides opposite to this angle theta, and the side adjacent to this angle. So given these two values, I have to use tangent. Again, you could also find your distance and then use pretty much any identity, but again, why make your life difficult? They're giving you an x and a y, just use those values. It's way easier. So again, inverse tangent of y over x will give me that particular angle. Now there is a slight problem. When you're given a rectangle or a triangle, no math teacher, when you're given a triangle, you don't care about the orientation. I mean, the angles are going to be the same, the values are going to be the same. It doesn't really matter. However, there's a problem with polar coordinates. Right now, if this were an axis, my x would be a positive value. But if I were this way, my x could be negative, or any combination. Don't say, what's going to happen here? And this only matters with the x. If your x is negative, or on the second or third quadrant, or on the left-hand side of the y-axis, if your x is negative, you're going to add 180 degrees, or you're going to add pi to it so it lands on the right-hand side. So here's the formula. If your x is greater than 0, just do normal tangent, inverse tangent, to find the angle. Nothing needs to change. If your x is less than 0, so negative, you're just going to add 180 or pi, depending on whether you're given degrees or radians, to your y over x, and then you're going to find the inverse tangent of that. Okay? Let's do a particular example now. Let's do example A. Hold on a second. Let's do example A. Now, in example A, I'm given the following values. I'm given S1 negative square root of 3. So step 1, let's find my R using Pythagorean theorem. Boogity. 1 squared plus negative square root of 3 squared. The 2 gets rid of this and also the negative, because remember, you can't have a negative. Whenever you square a negative number, you end up with a positive number. So you end up with 1 plus 3 or 2. So that's square root of 4, which is 2. Remember, even though you get, square root of 4 is positive, negative, use the positives only for the moment. So I know that my R is 2. And now I'm going to find the angle. Step 1 for the angle. Look at your x value. The x value is 1. That means it's a positive number. No change needs to happen. This was the coordinate. My x is positive. No change needs to happen. So in order to find the angle, I do inverse tangent of y over x. And that's going to give you your angle. Done. When you look at the book, you can tell that the angle is either 5 pi over 3 or negative pi over 3. Why do I get two answers, Prof? Simple. Yesterday, we saw that there were multiple ways to represent the exact same polar coordinates. The negative angle just went down. The positive angle went almost all the way around. Most of these problems will ask you find two pairs. You can always find the negative and the positive angle. That's going to give you the exact same results. Or if that's too confusing, all you have to do, just boom, add 2 pi. Again, if I have this particular value and I want to find a second pair, just add 2 pi. You're going to end up with the exact same answer. So both are correct, the negative angle or adding 2 pi. I strongly suggest you use the negative angle so you get used to working with negative angles. Because if you're always going to just add 2 pi, you're not going to get used to working with negative angles. And again, not that difficult. Negative angle and the positive counterpart. The easiest way to do this is to either find the positive angle and then subtract 2 pi, or the negative angle and add 2 pi, and you're gonna be done. So that's it for today's class. Tomorrow we're gonna go over rectangular to polar equations. That's a little bit trickier. So for today's homework, you're gonna do examples 1, 2, 9, 10, and also 13, 14, 15. These are all turning rectangular to polar. These are polar to rectangular, but 2 are in radians and 2 are in degrees. As always, after this video, please post in the class forum your attendance. As soon as you watch this video, attendance, start working the homework, upload it before 10. Any questions, chat or class forum. Have a great day, guys. Boom, see you soon.